In this video, I will show how to use the power rule to find the derivative of a function. So first, let's recall the power rule that says that if I'm looking for the derivative of a power function, I would bring the power down as a coefficient, and then I will take away 1 from the power. That means if I want to use the power rule, I have to write a function in a way that allows me to use the power rule. The given function is not written in such a way, so the first step will be to rewrite it. So I'm going to rewrite the first function in the sum as 4/3 times x squared. The second one is actually written in the way that we can use the power rule. The third one has to be rewritten as 2/3 times x to the power -2, and plus 4 is just a coefficient. So now to find the derivative of f, we have to find the derivative of each of these functions in the sum. And because the derivative of the sum and the difference is just the sum and the difference, or the difference of the derivatives, it suffices to just differentiate each of the function separately and then put it together using the appropriate operation. So derivative of 4/3 x squared is 4/3 times 2 times x to the power 2 minus 1. The derivative of 1/6 times x to the power 3/2, and here I'm also using the rule that allows me to take out the constant from the differentiation. That is, derivative of the constant times the function is just constant times the derivative of the function. That's why we can do what we're doing here. So here the power is 3.2, so I write 3.2 here, and I multiply by x to the power 3.2 minus 1. Next, we take the derivative of x to the power -2 by bringing -2 down and then taking 1 from -2. And derivative of 4 is just 0. So we can simplify this answer and write the final answer as 8/3 times x plus 3.2/6, which if we want to write it as a fraction, we would write it as 32/60, and then simplify as 16/3 x to the power 2.2, and 2/3 times -2 is 4/3 x to the power -3. So this is the final answer, and this is how we use the power rule to find the derivative of a function.